we're going to be solving multiple angle trigonometric equations. So that means instead of solving an equation that looks like this, sine of x equals 1/2, we'll now be looking at equations that look like this. Sine of 3x equals 1/2. And how do we find the solutions for this equation? Well, let me take you back to comparing the graphs of the functions y equals sine x and y equals sine 3x. So let's take a look at them. If we have y equals the sine of x, we know that the period is 2 pi. So let me just draw you a quick picture. Let me cut it into 4 subintervals so the graph looks decent. Right, we know the graph for one cycle of the sine function looks just about like that. Starting here at 0 and finishing at 2 pi, I have one cycle. When we're solving for the sine of x equals 1/2, we're finding all numbers for which the sine equals 1/2. So in the interval 0 to 2 pi, that would mean we're talking about this x value right here and this x value right here. Right? Those two x values represent the solutions to sine x equals 1/2 in the interval 0 to 2 pi. Now let's consider the function y equals sine 3x. So we have now we know that the period is going to be 2 pi divided by 3. So in the interval 0 to 2 pi, we would have 3 complete cycles of the sine. So let me draw a sketch of that. All right, look, let me see if I can do it here. There's one cycle. There's the next cycle. And there's the third cycle between the 0 and 2 pi. But the question is still the same. What are the numbers that would make this equation true? And between 0 and 2 pi, we would now have 6 numbers that would make it true. Right here we have an x value that gives us a y value of 1/2, and here we do, here's a 1/2, here's a y value of a 1/2, and here is 1 and a 6th one right there. We're trying to find all of the x coordinates of those points because they all have y values that equal a 1/2. But if we compare that to the graph y equals sine of x, let's consider the graph extended all the way to 6 pi. So we would see 3 cycles of this graph as well. Now between 0 and 6 pi, the sine of x also has 6 places where the y value is equal to 1/2. These 6 points will correspond to these. If we can find the x coordinates that correspond to all of these 6 points and divide them by 3, we'll get the x coordinates that go with all of these 6 points, and we'll have the solution to this particular equation. So let's see how that works. We're now going to solve the sine of 3x equals 1/2. And let's make a substitution so it becomes our friendly sine of x equals 1/2. So we're going to let u equal 3x. And if I do that, we have the sine of u equals 1/2. And I forgot to write the directions up here. And the directions were solve in the interval 0 to 2 pi. Right, we know there are an infinite number of solutions, but I'm interested in the solutions between 0 and 2 pi. So let's continue here. We know that the reference angle is pi over 6. We know that the sign is positive in the first and second quadrants. So we're going to write the solutions to the sine of u equals 1/2 using that information. So u would equal pi over 6 or 5 pi over 6. Our first and second quadrant angles that have a reference angle of pi over 6. But now I'm going to continue. I want all of the solutions to this equation that would take me out to 6 pi, so that when I divide by 3, I'll get all of the solutions to this equation between 0 and 2 pi. So let's do that. We're going to continue to all the way out to 6 pi. So we're going to find the angle coterminal to this one by adding 2 pi. We're going to add 2 pi to this one as well. Now we have 2 full rotations. We're going to have another full rotation. So we're going to add 2 pi. And remember, when you're adding 2 pi, you could think of it as adding 12 pi over 6. It makes the arithmetic a little bit easier. So we have 25 pi over 6. And we have 29 pi over 6. So those are our solutions to the equation sine of u equals 1/2, where u is between 0 and 6 pi. But let's put x back in, because that ultimately was the goal, to find x. So we have 3x equals pi over 6, 5 pi over 6, 13 pi over 6, 17 pi over 6, 25 pi over 6, and 29 pi over 6. And finally, if we divide by 3, we'll have x equals pi over 18, 5 pi over 18, and continue to divide by 3. And we have all of the solutions to sine of 3x equals 1/2 in the intervals 0 to 2 pi. Let's do another one. Let's say we're going to find all solutions in the interval 0 to 2 pi. And this time, let's solve the tangent of 2x equals -1. And let me get a drink. Let's make the substitution the way we did before in the previous example. We're going to let u equal 2x. So we have the tangent of u equals -1. And now we focus on solving this equation. Remember, the tangent of pi over 4 is equal to 1, so pi over 4 is our reference angle. But it is not one of the solutions, because the solutions will be in the second and fourth quadrants where the tangent is negative. So we're going to list our solutions that have pi over 4 as the reference angle or reference number in the second and fourth quadrants. So that would be 3 pi over 4 and 7 pi over 4. But those are just the solutions between 0 and 2 pi. We need to go all the way out to 4 pi so that when we divide by 2, we'll get all of the solutions between 0 and 2 pi for this original equation. So let's continue. We're going to add 2 pi to this. And remember, when the denominator is 4, when you're adding 2 pi, you're thinking of it as adding 8 pi over 4 just to make the arithmetic easier. So we have 11 pi over 4, adding 2 pi to this one, add 2 pi to this one, and we have 15 pi over 4. So let's put our 2x back in. So that means it's really 2x that's equal to 3 pi over 4, 7 pi over 4, 11 pi over 4, and 15 pi over 4. When we divide by 2, we have x equals 3 pi over 8, 7 pi over 8, 11 pi over 8, and 15 pi over 8. And notice all 4 of those are in the interval 0 to 2 pi. These numbers were between 0 and 4 pi, but when we divided by 2, it put all our solutions between 0 and 2 pi. Let me just mention one more thing, and that is this. You might want to find all the solutions. So let's just look at this equation again, getting rid of that restriction. Find all solutions, and we know there are an infinite number of them. Remember that we can start much like we did here. If you're looking at the solutions for this particular equation, right, we know that 3 pi over 4 was over here. And 7 pi over 4 was over here. And we were looking for all solutions to this particular equation with the u and the solutions would be those that were coterminal with 3 pi over 4 and 7 pi over 4. But remember, instead of taking 3 pi over 4 and adding 2 pi and adding 2 pi and adding multiples of 2 pi, and similarly doing the same thing with 7 pi over 4, adding 2 pi, adding 2 pi, and adding 2 pi, we could instead use this 3 pi over 4 and add multiples of pi, 3 pi over 4 plus pi, plus pi, plus pi, and add multiples of pi. So the solution is 3 pi over 4 plus n pi for this particular equation. But our goal is still to solve for x, so we pop the 2x back in, and we have 2x equals 3 pi over 4 plus n pi. And when we divide by 2 now, we get x equals 3 pi over 8 plus n pi over 2, right? Dividing this equation by 2. And remember, we should include the fact that n should be an integer. Remember, capital Z represents the set of integers, because we don't want n to be something like 1.3, right? N needs to be an integer, so you would be adding multiples of pi. And now we've solved another multiple angle trigonometric equation.